we
Hello,
missed, no, we have
hello.
everybody here. We have our fearless moderator, Mark Donnigan. So, Mark, I'm just going to turn it over to you, please.
Awesome. Well, good. You run a tight ship.
Thank you.
That's right. It's good. Well, hey, really excited to be here. So I am Mark Donnigan, and we have put together a group of panelists to talk about codecs. What we're specifically going to talk about today is navigating a multi-codec world. So I am going to apologize in advance if any of you were looking for the winner of the war, the famous codec battle. That's not what we're going to talk about. But seriously, over the next hour, there's just some phenomenal information that I know you're going to get. So let me real quick introduce our panelists, and then I've asked each of them to prepare. They have a slide, and they're going to be just a real short presentation about a particular codec standard that they're going to be focused on, and then we're going to go into a really phenomenal Q&A session. So hang with us, and I hope you really enjoy it. So we've got our panelists are Tom Vaughan is joining us from Beamr, and we have Zoe Liu from Visionular. We have Fabio Murra from Vnova, and we have Jan de Cook from Synamedia. And I'm guessing that pretty much everybody knows all of the companies represented. So you know they'll talk a little bit more in their comments about what they do. But what I would like to do here is share my screen so that we can start um, with Jan, who has put together a, okay, let's see here. All right. Um, Jan has put together a very nice overview of really the codec adoption landscape. And then we're going to have Tom talk about HEVC. We'll have Fabio tell us about LCEVC. And Zoe's going to talk about AV1. And then we're going to launch into our discussion. So let's jump into it. Jan?
All right. Yeah. Thanks, Mark. Thanks for letting me be a part of this panel. Yeah, I wanted to start this off with giving a brief overview of, well, this is my interpretation, of course, so I'll allow everyone and also my fellow panelists to disagree or agree here. But it's a bit talking about or representing what I would call, yeah, the multi-codec world with increasing fragmentation. So, I mean, Mark already mentioned it. It's not a winner-takes-all situation. We are in a multi-codec world where codecs do coexist. You have different standards. It's always been like that, actually, but we came from a pretty unique situation. And if you look at the top left, that's actually the broadcast situation where AVC is so dominant. And it has been like that for a while. And you still see it like right here. So don't try to derive the actual like absolute numbers. So I'm talking more about the relative movements here between and differences between broadcast and OTT, and then between now and 3 to 5 years. But if you look at the top left, you see AVC is so widespread. It's still the workhorse of broadcast. Interestingly, you still have MPEG-2 out there. It's definitely not that yet. We're still getting plenty of requests also to work on MPEG-2 compression efficiency. But of course, it's like yeah, you see the resemblance here with adoption curves. MPEG-2 is like sliding off, and then you have AVC moving along, and HEVC is really gaining traction. There's definitely some momentum here around HEVC, so that's a growing share of the market. Now, if you look at the bottom in the blue curve, you'll see MPEG-2 is shrinking. It'll still be around for a long time, longer than we ever expected, I think. Oh, any problem hearing me? Is this?
We can hear you.
We can hear you fine, Jan.
I saw a chat message appearing on the volume. So all right, I'll continue with the bottom. So MPEG-2 is sliding along. It's slowly moving away, but it'll still be there for a long time. AVC as well, still going to be there for a big share of the market. HEVC will continue to grow, but at the same time, and that's also the part of the codec wars, right? The codec wars. We have AV1, a new contender. We also have other codecs appearing. So my fellow panelists will be talking about EVC, LCVC. But VVC is definitely a strong contender here as well. And for AV1, we'll have to see if they gain some traction in the broadcast world, because of course, AV1 has been mainly driven on the OTT side. One of the reasons why we'll also see increasing fragmentation is just the changing or the move towards software-driven deployments. So that's also going to help move faster. And definitely OTT is an area where it can move fast. So you have, if you look at the right, the green side, there's still some older formats, but also here AVC is like, it's a safe bet. It's out there. It's still a big part of all internet traffic. HEVC also, it's picked up by several services. Several major OTT services are using it. Interestingly, VP9 occupies quite a share here, so I did want to bring this up. VP9 is out there. It has a big install base, a big ecosystem around it. And VP9 did capture a big share of the market that HEVC kind of left on the table with the licensing uncertainty, which was there for a long time. And then we're already seeing AV1. So there is a definite momentum around royalty-free as well. And then at the bottom, this is some of the movements I expect for the coming years. AV1 is going to continue to grow here. VVC could start taking a portion of the market as well. VP9 might still be out there. It's used in a lot of services still, but these are the movements that we kind of can expect. And of course, it's going so fast that in 3 to 5 years also AV2 is going to be on the horizon. But well, I think this kind of summarizes, so this unique situation of one codec captures all, or codecs like 3/4 of the market or more, we're not going to see that anytime soon. AVC was pretty unique in that. So that's how I came to this multi-codec world with a lot of fragmentation and more to come.
That's right. Awesome. Thanks, Jan. Tom?
Thanks, Mark. Yeah, good stuff, Jan. I agree with you. I think it's hard for us to really know the share of each coding standard because a lot of this goes on behind the scenes, and companies don't advertise what they're using, and it's entirely, even if it happens across the internet, you know, under the hood, and no one really knows which standard was selected, and that's, you know, a lot of the content is even encrypted and secured. For those who don't know, HEVC was a standard developed by the MPEG Motion Picture Experts Group under ISO and ITU, ratified in January 2013, so it's almost 8 years old. It has a good, it's good technology in terms of it being a really nice combination of compression efficiency, so significantly better than its predecessor, which is AVC H.264. Basically roughly twice as efficient. Efficiency always depends on how much compute power you throw at it and other factors, but roughly twice as efficient for maybe a 3 to 5x cost in additional compute to go get that compression efficiency. But compared to all other codecs, it's a pretty nice combination of compression efficiency and compute efficiency. It is used pretty much by every leading premium streaming service. Of all the streaming services, the one exception is YouTube. Google owns YouTube, and Google has its own formats that it promotes, so they have not used HEVC to my knowledge for content distribution. But if you're talking about premium content, you know, Netflix, Amazon, Hulu, Vudu, on and on, Disney, virtually all the 4K content you would watch, high dynamic range content, that is HEVC. So a lot of times when you watch the best quality content on your best screen in the house, that's HEVC, and it can deliver fantastic quality at reasonable bit rates. It was adopted, Apple kind of went all in on HEVC a few years back, and that has sort of helped the format. It was always supported, it was kind of quickly adopted by most device OEMs and chip companies, and virtually anyone who makes a competitive device that supports video implemented hardware support for HEVC, and that hasn't changed. So pretty much any competitive premium hardware device, mobile phones, tablets, PC chipsets, TVs, connected set-top boxes like Roku's and that sort of device, Apple TV, they're all HEVC capable devices. now we get into the challenge. If you haven't heard, and we'll touch on this more later, the licensing of the patents that were involved. So many companies came together to produce this standard. In the past, most companies pooled those patents, and those patents were available to license in mostly in one pool under a company called MPEG-LA. That didn't happen with HEVC, and the patent licensing fragmented into 3 major pools, and then there's still some companies that aren't in the pools, but they're also the companies that aren't in, for the most part, in the AVC pool either. And so, and initially one of the companies said, we're going to charge for content distribution. And that went off like that went over like a nuclear bomb in the industry. That didn't go over well. And it pretty much caused the creation of the Alliance for Open Media and AV1, which Zoe will talk about a little bit more later. I think everyone who founded that whole organization will tell you why they did that. And it was the attempt to charge for content distribution. After several years, that patent licensing, that pool, dropped that demand, backed off and said, never mind, just kidding. But it was several years too late when they figured out you can't do that and still be successful. That really doesn't work. And so content distribution is royalty free, with one exception. Ultra high def Blu-ray discs, they charge like 2 cents a Blu-ray disc. So optical disc media, there's a very small royalty. But for most everybody else in the whole world, it is royalty free to stream to devices where the device already supports HEVC, natively in hardware or software. So that gets down to where the kind of Achilles heel of HEVC is that for basic web streaming into a web browser, it's supported by Safari and Edge on devices that have hardware HEVC support. And there's some options to get software decoders downloaded and so on. But Safari and Edge have a minority of the market share of the browser world. And Chrome and Firefox combined have a large majority of the market share, and it is actively blocked by those browsers. In other words, even if the device you have has a hardware HEVC decoder and the server who wants to send the content out says, hey, I have this available in HEVC, those browsers very explicitly don't support HEVC as a format in the web standards, HTML5 as a video object. So for that reason, companies whose primary audience comes to them through a web browser, let's say like Twitch, they won't, they're really going to hesitate to use HEVC because it would only satisfy a small percentage of their audience, and so the cost benefit doesn't work out as well as going with more lowest common denominator formats. Now, if you're a premium service and you can convince people to use your app on a Roku or set-top box, within a TV itself, on a mobile device, so all the heavyweights, they fit that description, HEVC is a great choice. It's no problem, right? But if you're just streaming content over the web into a browser, this is the Achilles heel for HEVC right now. So that's a quick overview.
Got it. Thanks, Tom. Okay, Fabio.
Mark, and thank you for having me here. I kind of represent MPEG-5 LCVC, I guess, during this panel. And I just want to put it in the context of all of these other standards. And MPEG-5 LCVC, which stands for Low Complexity Enhancement Video Coding, is the latest of the MPEG standards. It got to Final Draft International Standard in October, but it's the first of a kind, if you want. Is the first standard that is aimed at improving the performance of any codec. And we will explore this a little bit more during the panel, but this could be any MPEG codec or non-MPEG codec, which is fairly new for MPEG itself. So it's not an alternative to the other codecs that we are discussing today, but it's a way to work with them to improve the performance of them. By performance, I mean both the compression efficiency and the computational efficiency. So the number of bits that are necessary to achieve a given quality, and the cycles that are necessary to achieve that quality itself. So you see here on the bar chart, it aims at addressing that, what's the trade-off, if you want, that's always been in the world of compression, that of kind of progressively increase the compression performance. And we've come a long way from the days of MPEG-1 and 20 to 30 to 1 compression ratios to 500, 1,000 to 1 now, which is amazing. But yet, despite Moore's law and the advances in compute available, we're still optimizing compression, every time, every generation, because every generation we get a 7 to 10x complexity increase in these encoders. So LCVC is different. So it is aimed at working together with this, what we call base encoder, and to improve both of these dimensions. So how it does that? Quick representation here with this kind of satellite looking image, but it does that by kind of dividing, if you want, the roles and giving a lower resolution base, a lower resolution base encoder could be AVC, HEVC, VVC, AV1. The task of encoding, as I said, this lower resolution, usually this means this base encoder works more effectively with more bits and more tools available to do things very well at that lower resolution. And then we use the LCVC kind of enhancement layer, a hierarchical structure, if you want, which is not new to compression, but it is used in a different way to compare to before. Kind of different tools, different ways to compress the image. And really it's this combination of ways to dealing with different components of a video that makes it efficient in many aspects, in many purposes. So in a nutshell, I mean, it is a standard. The bitstream is being ratified and it's available for implementation. It is a different standard. It is an enhancement, and not to forget, it is low complexity. So by design and being just an enhancement, so a layer that goes on top of something that is existing, it is in its implementation kind of designed to be deployable in software on devices that are currently out there in the market. And I think we were going to touch upon these aspects a little bit during the panel.
Yeah, absolutely. Thank you. All right, Zoe, AV1.
Yeah, so AV1 was finalized in June of 2018. So it's a latecomer to this arena. AV1 basically, as already mentioned by other panelists already, and it's a royalty-free open source video codec. And more, I'd like to highlight that it's not only royalty-free, it also represents some of the most advanced video codec technologies. Because as opposed to its predecessor VP9, AV1 has included more than 100 neo-coding tools in the standard. By now, as shown in this figure, AV1 is mainly was pushed out and also maintained by the so-called Alliance of Open Media. So this consortium right now has already included 45 members globally, and including the 13 founding member or board members here. And also, we got a screenshot simply from the Alliance of Open Media website. Here is basically there's the current status of AV1. So it's mainly because it's a 2-year-old standard, so we heavily still rely on the software solutions, including the software encoders and the software decoders. Especially before the wide availability of the hardware decoding support. Right now, the software decoder plays a very significant role for AV1. There's several software decoders available. already, for example, the David maintained mainly by VideoLAN and FMPEG already shows a great performance over both PC platforms and mobile platforms. For example, all the browsers except for one, Safari, including Chrome and Firefox already included the David inside and supporting the streaming and playback of Ib1. For example, if you watch YouTube, and besides the previously available format of 264 and VP9, almost all the most viewed videos already provided the format of Ib1 for the time being. And also, it's worth mentioning there's a 3 software open source encoders also available. The LibOM behind the standard and also SVT Ib1 has shown great multi-threading performance, and also Ravi, who is trying to maintain a light computational resources. Beyond all this software encoder and decoders, it's worth mentioning that the hardware support, especially on the decoder side, is already pick up and fast expanding. So we all know that for any new codec standard, the hardware decoding support is kind of symbolized the build and expanding of the ecosystem. So we gave also a list of the current already announced or already available hardware support for Ib1, including SoCs, and also here is the OEMs, the mobile platforms, and TVs, and set-top box. And we expect in the year of 2021, we should expect more hardware support coming along for the decoder side. And also, we all know that because of the including of a lot of new coding tools into Ib1 encoder is has left the impression, I think, to the community that it is slow, and we want to see that, want to show that it's under all kinds of effort. Of course, also include our team's effort. This is mainly of the effort from the whole community. And Ib1 already showed the great performance. Here we show the figure from the public result from the Moscow State University annual codec evaluation result that was published this March for the 4K in the slower speed levels. That Ib1 has won the first place compared to other encoders. And also we see that is Ib1 also, like I just mentioned, including a lot of new coding tools for the first place, for the first time into its codec standard. For example, Ib1 includes the screen content coding tools. And the screen content nowadays plays, I think, is also very significant role. For example, we are sharing slides, and there's a lot of remote desktop sharing under like remote work, especially under the pandemic. So here we show a figure that if you optimize the Ib1, and it can show that compared against the x264, very fast, that Ib1 can only need to use under 20%, so less than a quarter of the bit rate consumed by that of x264 to achieve the same or even better visual quality. Of course, Ib1 is still slow. It's about 1/3 of the speed of that of x264, but on the single thread over the PC platform, it's already been able to achieve more than 45 frames per second in terms of the encoding speed. So that's why we're trying to pass out the message that the whole Ib1 community is still trying hard to push it forward. But at this time, for VOD, for live streaming, and even for real-time communications with interactive communications, Ib1 is sort of being ready for deployment at this moment. That's it. Thanks.
That's great. Thank you, panelists. Thanks, Zoe. Okay, so we are I think that was just a phenomenal. I should have warned you all to hold on to your seats because we were going to speed through an update. There's so much information given, but I think that was just absolutely a phenomenal overview and hopefully very helpful. We're going to transition now into a panel discussion, and I do see a couple questions coming in. I encourage you, feel free to type in the Q&A. And we'll do our best to get to them. Probably some of them we'll answer just in the course of the conversation, but just so you know, be sure to enter your questions. We do want this to be as interactive as possible. So I think a really good place to start is, when we're looking at codec decisions, and we've already made a very strong case, beginning with Jan's overview of just the codec landscape and where adoption is for the various standards. We're in a multi-codec world, and so we've made that case, and I don't think we need to say much more about that. But I'd like to start talking about applications, because some of these standards have been optimized. Maybe it's too much of a stretch to say they were built for some specific use cases, but some of them have clearly been optimized in certain directions, that lend themselves better for, example, maybe premium VOD. And so let's start there, because I think that a lot in the audience are probably involved in media and entertainment workflows, although we are absolutely going to touch on RTC and user-generated. But let's start with premium VOD, and especially kind of the holy grail 4K, 8K. And I'd like to just, have each of you share some insights, share some thoughts on where some of these codecs fall in terms of, where they can really meet the requirements of a premium VOD workflow, where maybe there's some things coming, and if there's any standards that maybe are not as applicable. Let's talk about that too. And while we're talking about premium VOD, let's also add live in there, because, I think now live and VOD, the lines are getting blurred a little bit. So, I want to throw that ball out there to the panel, and whoever wants to grab it and give some thoughts, go for it.
Okay, I think I can go first, and then because just now I went last. It's going to be quick. So for Ib1, I didn't mention in my introduction about the OTT for the premium content. Actually, Ib1 for the first time is also include the coding to our film grain, because we all know that a lot of premium content is heavily rely on the presentation of the film grain in a good way. So Ib1 for the first time including the film grain's main body, meaning that all the Ib1 decoders had to support this coding to our film grain. By using that, can actually potentially largely reduce the bandwidth, because it's basically doing the degrain on the encoder side and then doing the video, the film grain synthesis on the decoder. So within the bitstream, it doesn't have to present a lot of film grain noise as a noise format. On the other hand, Ib1 also support 422 10-bit instrument body. As we see that is Ib1 still slow relatively to other encoders. So for VOD streaming, where we can encode the premium content offline, but actually streaming live, then I think it's also a good scenario to launch Ib1 to show that the standard advantage, where it can just achieve great quality at less bandwidth. So in this, I think, scenario, I would like to see that Ib1 also could be a good candidate. But we all know that the ecosystem is still being built. We need a great software. Right now, we have the software decoder solution, but really need the wide availability of the hardware support. Also, I think at the same time, all the content, when we try to encode that, is also need a faster encode to handle this, because there's a lot of premium content. It's different from the UGC, because the UGC just got updated. Maybe mainly you just need to re-encode that for the newly updated content. But there's a lot of style content for premium that need to re-encode if you provide the Ib1 format. And by the way, Netflix already rolled out lower resolution version for Ib1 early this year. And also for DRM, we want to see that there's a DRM already, it's already standards down there, the syntax is out, and there also demo already show that it's Ib1 plus DRM is quite ready for deployment. That's it.
I'd like to say something about kind of probably another angle when you talk about 4K, 8K, and kind of premium OTT. I take Zoe's point about the content, right? And a lot of the modern compression standards have tools that are kind of designed and tuned to make sure that they work best with some specific content, whether it's film grain, whether it's animation, whether it's gaming content, whether it's sports content. And LCVC to an extent has that, although it has a much less number of tools. I mean, we're talking 10, 12 tools compared to the hundreds or more there are in these compression standards. So we tend to kind of leverage that base codec capabilities when it comes to the content type, for example. But there's one thing that when you go 4K, 8K, that's really undeniable. That is the size of the bit stream, right? It's the size of the picture that you have to compress, and the consideration that you have to take for the channel that you have to push it through. So compression efficiency is definitely important. But also the problem of kind of simulcasting, I think, especially if you're on broadcast, we're talking mostly streaming an OTT or unicast type of application. But, when you have to send out an HD, a 4K, an 8K channel, it becomes a logistical, a management issue from your video delivery workflow. So with LCVC, actually, we are in a few trials where we use the enhancement layer, which is very efficient at encoding the difference, especially at those high resolutions. When you go HD to 4K, 4K to 8K, you're left with really that kind of fine detail that LCVC or the enhancement layer is very good at encoding. And there we're experimenting with, or we're trialing, both in broadcast and in OTT, in sending different streams, where the recipients can just get the HD plus the enhancements. In HD is kind of hybrid broadcast broadband or broadcast or broadband. So there, by having this enhancement, and it applies to HDR as well, you kind of get a little bit more creative in the way you deliver the streams, and therefore you use and optimize the bandwidth that you have available. It's just another angle to consider, I thought.
Interesting. Tom, Jan, any thoughts or comments about these codecs, relating to application, specifically premium content?
Well, I agree with the previous panelists as well. And I mean, the delivery is definitely going to be an issue. And also, I mean, the Ib1 on the Ib1, that Ib1 is ready for prime time as well. That's definitely something worth mentioning. But when it comes to 4K out in the field right now, I mean, HEVC is, of course, a very strong codec out there, a very strong format. But interestingly, also for a lot of the premium content at the moment, VP9 is an interesting format. I mean, HEVC has a huge install base, billions of devices, but also VP9 has a huge ecosystem around it. So for 4K, you also see services using that as a current solution, which you can, I mean, all the support is out there, so it's ready to use. And at some point, yeah, you're going to see Ib1, other codecs appearing, of course. But at the moment, there's definitely those choices, HEVC, VP9, that you can just benefit from already.
Interesting.
Yeah, there's a lot of factors. I mean, Jan has good experience having previously worked for Netflix. You know, understanding how an operator thinks of these decisions, and there's a lot of factors that go into it. And first of all, you're already probably running a service, and that service is probably already multi-codec, unless you're, you know, let's say a live linear operator, you know, over the air broadcaster or something like that. But even those guys, right, they have some legacy MPEG-2 because some MPEG-2 devices are out there. They have some AVC, they have some HEVC, all the typical, you know, cable, satellite, over the air video distributors. So there's all these different factors. You know, technologists, we think about compression efficiency and then the coding tools and all that. That's all really nice. That's the least of people's concerns. What is it, you know, adding another codec is a huge cost. Am I gonna add that for all my content or just some of my content? I have to do all that encoding. I have to have the storage. I have to pay for CDN costs. Then I have to upgrade all my player and client applications to make sure they're compatible with this. That's a ton of testing. I'm going to have to do that going forward every month, every year, for as long as I support that coding standard. So they don't necessarily want to support every coding standard possible. They want to support as few as possible to cover the widest range of customers and clients and applications and so on. Then you get into, so we talk about VOD, you know, for 4K, if my client base, if the customer's client device, you know, I can get them to download an app and it can go right into a Roku or a TV or something. HEVC is pretty dominant. If they're coming to me through a browser, I'm using AVC and maybe VP9 and maybe now AV1 as well. You know, there's all kinds of technical factors, but you know, those are the choices if I'm predominantly in a browser. There's other factors, even like, you know, I've heard from certain operators that just having a worldwide, you know, internationally recognized standards body like ISO ITU blessing a standard means something versus the Alliance for Open Media. Like, it's crazy what all the factors are, right? But live, I need live encoders, right? I need maybe contribution encoders, what we call, right? So from the event, sending that out to, you know, services that do the distribution, maybe a higher quality version of that signal. And then I need live distribution encoders. So there's a ton of technical factors as well. You know, is this actually feasible? AV1, as we kind of know, Zoe was talking about the hardware support that's going to be out there and all that. It's nascent. It's in the very early stages of chips having, you know, real-time encoding. And so you're just probably not going to see too much live AV1 this year or in the next year, right? Whereas HEVC is quite mature. So for live 4K HDR, you can expect HEVC to dominate live 4K HDR. And it has all the technical capabilities you need, right? VVC we didn't really talk about. That's a brand new ratified standard from that same group. It's the successor to HEVC. And we'll talk a little bit more about the legal issues, but there's a chance, a good chance, and there's a whole trade organization called the MCIF, the Media Coding Industry Forum, which is working to prevent the kind of legal snafu we had with patent licensing with HEVC in VVC, and they have some tricks up their sleeves and some tools to be able to help accomplish that. And I think there's a fairly good chance that they can accomplish licensing certainty and coherence. We don't know if it's reasonable, we don't know what the cost will be, but if we can at least have certainty as to where to go to get all the patents and that there's not some uncertainty as patents lurking out in the deep, ready to surface and cause me trouble, that would be the main thing. And it will take some time to know that, probably at least a year to know whether the licensing is going to work out with VVC. But technically it's strong. If that licensing works out, then there's a future there. So right now I would say we know kind of what all the coding options are for VOD. for live, we're certainly hoping after 8 years of working with HEVC to see live 4K become a thing. You know, rather than us watching live sports in 720p 60, we think you should be watching live sports in 4K 60 10-bit HDR, because it's massively better, and we think HEVC is going to play the strongest role there in the coming years.
Yeah, absolutely. I've got, so I'm looking at Q&A here, and I'm going to go ahead and ask a few questions that have come in, because, you know, it's a great time for it. So one of them is, you know, and this is a good one. Could it be better that we have less formats for the ecosystem? And then he goes on to say, or kind of ask the question, make the observation, that way investments will deliver more value as they could be used more widely. So you know, we made the statement, we're in a fragmented multi-codec world, but maybe it's worth taking 5 minutes to talk about, you know, why is that? And is there a way to get back to where, you know, maybe it's not a single standard, but maybe there's 2 formats and there's not, you know, 3, 4, 5, 6, like it looks like we're going to have. Somebody wanna jump on that?
I'll just start by saying, you know, and Alberto knows this well because he's participated in standardization.
Yeah. The person who asked the question knows the answer.
As well as some of our panelists here understand how that works, right? You know, it's the business issue. It was the patent licensing. It's the reason there is a quote unquote, you know, royalty-free effort, which, by the way, isn't really royalty-free on the hardware side right now. There's a patent pool out there for Ib1 that, you know, in my opinion, is probably going to stand. It's not unreasonable, the per unit cost or any of the terms or anything like that. And there's no attempt to charge for content distribution, but Sysvel is probably going to get a few pennies per device ultimately, is my guess. But it's that business legal issue that is the primary issue why we have kind of 2 competing sets of standards bodies and 2 worlds of new standards. And it probably would be good if that could be sorted out and all the people could join forces and build one. But it is also at the same time, the attempt to make something royalty free, it's kind of a, you know, you get into what should the price be? Well, when you go to 0, it changes a lot of things legally and technologically wise. It ends a lot of certain debates and so on. So it may not be possible to rejoin the, you know, the Alliance for Open Media world and the MPEG coding standards world into a single branch again. They're likely to continue to do their thing and join, you know, separately produce competing standards. Competition is a good thing. And in the end, the individual device OEMs more or less end up having to support every standard that has any reasonable amount of usage. And they just charge everybody more for whatever they have to put in it. And that's that. They all have to do it. So there's not one that has an advantage or disadvantage there, but services, video services can choose which standards make sense to them, and that can sort of coexist.
Yeah, that point on choice, sorry if I can jump in, because we touched, and Tom, you touched a couple of times about the licensing and the royalties issues, and I guess, I don't know, we'll talk a little bit more in depth about that. But I guess cost for a technology is one aspect. I think we had kind of dualistic approaches in technologies before, you know, from VHS, Betamax, MPEG, and you know, we had the ON2s, we had the real videos, we had like other people trying to kind of come up with alternative solutions to that of the established MPEG kind of progress on video compression technology, and that's a good thing. I think that is a good thing. It's a good thing in competition. It's you know, monopolistic approach, I think it will stifle the technology progress, if anything. Ultimately, however, we live in a multi-codec standard because of legacy as well, right? Because of the fact that we have to wait for any given standard you know, the cycles that it takes to ratify it, to harden it in silicon, to get it into devices, for devices to get out there in the market in a number that is large enough for a service to target them, right? For a service to be able to invest the amount of money necessary in the infrastructure to target those devices and those new capabilities. And this is why, as Jan said, you know, we're still living with a lot of MPEG-2, right? It's, you know, 30 years old, but, you know, there's a lot of set-top boxes out there that we still have to replace. So it's inevitable, I think, unfortunately, or fortunately, I think, from my perspective, and from all of our perspective, because we work in compression, is inevitable, but it's a good thing for those services who can intelligently make the right decisions about which standards to deploy for which services. It could really make for a unique selling proposition and a competitive advantage.
Jan, I want to ask you, Synamedia largely, from what I understand, is, you know, dealing with operators, service providers, broadcasters. That's largely the world that you service. And it seems like that world has really come down on the side of MPEG, ISO, ITU. Is that true? Certainly we can look back and see that's true, but moving forward, is that going to continue, or is sort of that wall being broken down and like, you know, AOM, AV1, et cetera, you know, there's interest there, or what are you seeing from Synamedia's perspective?
Yeah, I mean, that's a really good question, right? That's also why I kind of made the distinction on the slide between the broadcast world and the OTT world.
Yeah.
I mean, in the end, and also related to the previous question, it's all about, it's an economic reality. You had this amazing standard ABC, which is like brilliant at the time. And then you had HEVC following it, also brilliant technology, but there was just friction, there's economic friction. And you see technology is ahead, but you cannot adopt HEVC because of the uncertainty. That's improving, but it did cause VP9 to gain market share, and then also the Alliance for Open Media to get started, right? Now to Mark, to get close to your question, so in the broadcast world, you do feel that like transition from MPEG-2 to AVC, HEVC is definitely gaining there, and then you're getting questions around VDC. You have discussions around it as well. And one of the things that I see, perhaps, I mean, I don't think there's anything really blocking AV1 from gaining share of the pie there, but there's just less pressure there from the companies. I mean, to be honest, I mean, it's also one of the reasons why Synamedia, why we joined the Alliance for Open Media, is also to have more representation on the, let's say, service provider broadcast side. Because nothing is really stopping it. There's just less momentum to drive it forward, I think. While on the OTT side, there's a clear economic driver behind it as well. And that's why I'm wondering on the OTT side if VBC is going to gain a foothold or not, but AV1 is definitely going to do it. And on my slide, I mean, there's a question around AV1 on the broadcast side. So at the moment, it's not a huge thing yet. Maybe it'll happen. But for the moment, I see more momentum building around VBC on that side. But it's all open. I don't have a crystal ball, so also my slide is just like based on like current trends. But this could all change if AV1 gets stronger, or AV1 could just not get any traction there. That's possible.
Yeah. Let's move the conversation along and now talk about our tech stacks. So, you know, when you start saying, hey, I'm building a transcoder, I'm operating a transcoder, but guess what? Maybe even, you know, there's becoming more applications on a wider range of devices where I may want to, in my ABR stack, deliver HEVC and AVC, because maybe I've got, you know, two 4K profiles, and then, you know, I'm using my existing AVC encodes for, you know, HD and below. Let's talk about, what that looks like. What are considerations now for dealing with multiple codecs when previously, I even though maybe I did support different codecs, sorry, I basically maybe had kind of a mobile set of profiles and I had a set-top box or a media player and, some other connected device, but it was a single codec or a single standard represented for each. Does anybody have some insights to share, some experiences, maybe some real world, case studies about what that looks like, considerations?
I think I definitely have some input here.
Yeah.
I mean, it's so yeah. I mean, there's just no way around it. It is a multi-codec world. There's going to be more complex that situation where you can just use AVC. Just by that, I mean, you can still reach all the clients out there, but that was a pretty unique situation. If you want to go to higher resolution and so on, yeah, you have to start making choices. You have AVC versus VP9. They have slightly different client support, and I think the key here is really that client support. Like, what is the distribution of clients out there for your service? If you have if you need a lot of browser support, like Chrome, Firefox, and so on, I mean, VP9 is a good choice. I mean, if you have a lot of iOS devices, yeah, maybe HEVC is a good support. So you still have that split up. So it's a bit of that unfortunate reality that you will have to make. I mean, you can still use AVC as your workhorse or your long tail for your long tail content, but you'll have to add probably pairs of codecs on top of that, VP9 HEVC in the future, perhaps VVC and AV1. But in terms of implementation then and deployment, yes, I mean, you're making those streams more efficient, but your footprint is going to multiply, of course. So that's something to take into account. Also, if you have premium content, if you have HDR10, if you have Dolby Vision, just SDR, these are all different streams. So that'll be an important aspect. So I think client support, footprint related to that, your CDN and your cache efficiency. I mean, if you keep adding more codecs, you're going to end up in a situation where you have these maybe orphan streams, which going to end up in some low layer of your CDN caches.
Yeah.
And then the QE, even though the stream is more efficient, the QE is going to be not as good as your maybe less efficient codecs. So that also plays a role. So that trade-off between footprint cost and streaming bits over the internet, that is an important one as well. And then complexity, of course, encoder complexity, decoder complexity. Encoder complexity, I see on the OTT side, I mean, usually you can spend quite some cycles extra encoding these and optimizing the streams with AV1 or HEVC or VVC in the future. It's a bit less of a concern. In real-time deployments, of course, you really want to get efficient implementations, possibly hardware. Same on the decoder side. So again, client support is very important, but also in the beginning, AV1 was tricky to deploy because just like battery life on mobile devices was really tricky. So that's also something to take into account. But as soon as you have the hardware support, and you do see that, you have it for HEVC, VP9, AV1 is really gaining maturity. So you have a lot of, I mean, you have the SoCs rolling out hardware support to have efficient AV1 decoding even. So
yeah,
that's some of the considerations that you have to take into account when deciding it.
Yeah, that's great. So I'm doing a quick time.
Sorry.
Sorry, Zoe, I'm doing a quick time check. I want you to make a comment, and then let's try and hit some Q&A. And I think we're coming up against our time, unless we can extend, Brian. Brian's on mute, but Zoe, please go. I'm just calling attention that we're running out.
I really second what Yang had just mentioned regarding the client side for the multi-codec world, because for example, we already trying to serve one actually OTT provider, and they provide the OTT streaming actually to the Southeast Asian area and India area, and they already deployed AV1. using the open source, and they came to us just they want to find a better one. And we asked them, they said their users really mainly consume the bitstreams over mobile devices. And we said there's no decoder. And they mentioned that their user scenario mainly on the low bitrate, low resolution set, even though the users watching the premium content, the movies and the shows. So in that scenario, what their users really care about is within the very limited bandwidth, whether they can still try to make the most use of the available bandwidth. So really want to look for an encoder that can even achieve a better code efficiency. And so on that side, code efficiency wins. And also they just simply deploy the software decoder that could be good enough supported by even the mid-end or lower-end mobile devices. So that's what I mentioned is really I think the market, the user, their requests are actually driving the whole ecosystem, like for example, for the Ib1, driving it forward. On the other side, we all mentioned that the ABC, the 234 has been universally available, but I want to mention one thing is the open source encoder X264 plays also a very significant role in making this ABC community, I think, really kind of friendly to a lot of users. So the open source encoders for example, VP8, VP9 behind the WebRTC plays a significant role right now for the real-time communication scenario, especially under the pandemic. We all need communication even with this conference working online. So what I meant is just a second, what Yang has mentioned, the client, the user experience, because eventually whatever codec we serve, we just want to meet the user's request to provide the best quality of experience.
Yeah. Yeah, I think that's just a super key point. At the end of the day, we're all trying to optimize for the best user experience. And if our users have a varying range of capability in their devices, then if we're really going to optimize for the best experience, we're going to end up delivering in different formats. It's kind of a given. I want to ask one. I'm going to assume that we still have a couple minutes that we can go slightly long here. There's one question that came in that I think is interesting. There's a number of questions, but we're not going to be able to get to all of them. But somebody was asking, maybe it was just answered, but somebody was asking about moving from on-prem to the cloud in terms of encoding, and also whether whether HEVC is kind of, I think what the question was, is HEVC in a position to sort of replace H.264 AVC, but what do we, real quick, what are we seeing there in terms of, on-prem encoding operations and moving to the cloud?
Yeah, I jumped in and took a shot at answering that in the chat, but in the Q&A, but there's been a trend everywhere in the world for everything to go from on-prem to the cloud. It really depends on who you are. If you're Facebook, you run your own data centers. If you're, Amazon and, even Comcast or, the kind of telco operators, they've had their many points of presence. So they have many smaller data centers around the world, and they have their, for content security reasons, a lot of stuff stays inside their, what we would call on-prem. But everybody else in general moving to the public cloud, and therefore there's a desire for software-based, full software-based stack. But everything depends, right? It depends on all the specifics, how people make those business and technical decisions. And then the other question was, is HEVC the most used encoding format for 4K in the cloud? Yeah, for premium content distribution, I think it's pretty clear HEVC is the dominant format. For user-generated content, and keep in mind, I should have mentioned, when you shoot 4K on your phone, it's almost certainly HEVC, right? The Apple started it, but Samsung and all the Android device OEMs followed to offer 4K recording in our, video cameras in our pocket. Everyone has a video camera in their pocket, right? So that's a 4K video camera. That's HEVC in almost certainly. But you know, user-generated video is shared through the web. Generally, that goes up to the service. It's re-encoded and in the format they want, so they have some uniformity there.
Awesome. Okay. We said that we were going to talk a little bit about licensing. We definitely don't have time to have a whole discussion, but you know, let's take like 1 minute and just give kind of a really quick. Yeah, Brian says we need to wrap, so literally 1 minute, really quick. What is the current state of not HEVC but VVC? Are we going to have a repeat of HEVC? And where are we at with AV1? Whoever wants to grab it, you got 1 minute.
Maybe we should have 30 seconds each. I don't know, Mark, if it works that way, because when it comes to, there's a question from Alberto here, which I think is very relevant as well. He says, okay, we have all these codecs, right? We put them in SoCs because these devices need them. Should they pay for 9? And I think it's crucial that actually the licensing models change as we go forward. These are not single use or single purpose devices like a set-top box would have been in the past. You know, these are platforms that are compute platforms that are used for an infinity of things. And I get my laptop shipped with a whole sorts of software, and I just pay if I use it. So, you know, I think in the future, the licensing models will have to change. And I just say one thing about LCVC. It hasn't been announced yet. It will be announced shortly, but it will be different, right? I think we realize that it's an enhancement. We realize that the licensing models have to change, and ultimately, just to close my remarks, I think we wanted to make it low complexity as well.
Okay, awesome. Zoe, do you have any really quick comment on AV1 licensing?
I think AV1 is royalty free. That's it.
Yeah. Okay. All right. You know what? This is so Brian was very gracious and extended our panel from 45 minutes to an hour. Clearly, we should have gone to an hour and a half. But anyway, you know, thank you, panelists. Thank you for joining, and I hope those in the audience really got a lot out of this time. So thank you again.
Hey, great job, Mark. Thank you so much. Yes, I learned a lot, and I hope our audience did as well. My takeaways are, like everything in life, there isn't always just one answer, and it's situational and it's based on the application. And so I was very informed by that. We're going to thank you, panelists. You can